Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will start another topic of IGCSE Physics, and our topic for today is resistance and mains electricity. Electrical resistance is a measure of the opposition to the flow of current. It basically tries to stop the flow of current in a wire. The unit of resistance is ohm. It comes from the Ohm's law. Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through it, provided that the temperature remains constant. The formula of Ohm's law is that V is equal to I into R, which is voltage is equal to current multiplied by resistance. There are a few factors which affect resistance, which are materials, length, cross-sectional area, and temperature. Different materials have different resistivities. For example, conductors like copper have low resistance, while insulators like rubber have high resistance. Resistance increases with the length of the conductor. Resistance decreases with an increase in the cross-sectional area. In most cases, the resistance increases with an increase in the temperature. There are many types of resistors, but we will learn about 5 of them, which are fixed resistors, diode, LDR, which is the light dependent resistor, thermistors, and a variable resistor. Fixed resistors are the one which have a resistance of a fixed value and that cannot be changed. It is commonly used in carbon film resistors, metal film resistors. Another one is diode. Diode is an interesting one. A diode allows the current to flow in one direction only. It has low resistance in one direction and high resistance in another one. LDR is a light dependent resistor. Resistance decreases as light intensity increases. Used in applications which has automatic lighting. Thermistor is a type of resistor whose resistance changes significantly with temperature. Normally, resistance decreases as the temperature increases. Used in temperature sensing and control applications. The most useful one would be the variable resistor. Here, we can manually set the resistance of the resistor. It is used in a lot of applications. A variable resistor is used to set the brightness of a light. Let's look at some examples and problems considering the Ohm's law. When a voltage of 12 volt is applied across a doorbell, there is a current of 0.1 ampere. We have to calculate the resistance of the doorbell. We know the formula is V is equal to I into R, but we have to calculate the resistance, so we have to rearrange this equation. R is equal to V by I. Therefore, 12 volt divided by 0.1 ampere. The answer would be 120 ohms. Let's look at another example. In example 2, the circuit on the right contains a 12 volt battery and two resistors connected in series. We have to calculate the current in each of the resistors, the voltage across each resistor. So, at first we have to calculate the current. The total resistance in the current must pass through is 2 plus 4. As it is a series circuit, we can just normally add the resistance of the total. So the total resistance would be 2 plus 4, which is 6 ohms. The current in the circuit therefore would be I is equal to V divided by R, which would be 12 divided by 6 ohms. The answer would come out as 2 amperes. In number B, we have to calculate the voltage across each resistor. Using V is equal to I into R, for the 2 ohm resistor, V is equal to 2 ampere into 2 ohms. The answer would be 4 volts. But for the 4 ohm resistor, V is equal to 2 ampere into 4 ohms. The answer would be 8 volts. There are mainly two types of current. One is alternating current and another one is the direct current. Alternating current changes direction periodically. Mains electricity, which is used in our household, is alternating current. But the current which is used in our battery, camera, or mobile phone is direct current. So to learn more about this, we have to learn about two formulas, which are about electrical power and energy consumption. Power is equal to V into I, which is power is equal to voltage multiplied by current. Let's look at an example how this is used. An appliance with a voltage of 230 volts and a current of 2 amperes. So the power consumed would be P is equal to 230 multiplied by 2 ampere, which would come out as 460 watts. Another formula would be the energy consumption. The formula of this is energy is equal to power multiplied by time. Let's look at an example to understand better. An appliance rated at a 1.5 kilowatt operates for 4 hours. The energy consumed is, we have to at first convert kilo into watt. So we know that 1 kilowatt is 1000 watts, and 1 hour would include 3600 seconds. So E is equal to 1.5 into 1000 multiplied by 4 into 3600. The answer would be 21,060,000 joules. Electricity include fuses, circuit breakers, and earth wires. Fuses protect the circuit by breaking the connection if the current is too high. Circuit breakers automatically switch off the electrical supply when a fault is detected. Electrical wire provide a path for the current to the ground in case of a fault, preventing electric shocks. In most of the cases now, fuse and circuit breakers are used. In case of fuses, there are several sizes of fuses. The most common domestic applications in the UK are 3 ampere, 5 ampere and 13 ampere fuse. The correct fuse of application can be easily measured. For example, if a fan uses 10 ampere of fuse, we would have to use something of a fuse which is a little bit high but not too high. So if something is using 10 ampere of current, we would have to use 13 ampere of a fuse, as it is the most common one. Anything less or more than that could result in a fault of the device. So safety features provide a safer way for the applications to work properly without a damage to that particular device. That's all for today, students. We have learned today about Ohm's law, types of resistors, types of currents, safety features which involve mains electricity, and many more. Stay with us to learn more about IGCSE Physics and other courses as we post regularly on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.